Hi students, now let's see the translation of assignment statement in the compiler design using the syntax direct translation technique. So in syntax direct translation, assignment statement is mainly deals with expressions. So we are discussing about the assignment statements. So that assignment statements is having the arithmetic operators. So here it is mainly deals with expressions. The expression can be a type of real, integer, array and records. Okay. So let's see the grammar. This is the grammar. S determines id is equal to e determines e1 plus e2, e determines e1 into e2 and e is equal to e1 and e determines id. So this is the grammar. For this grammar, we have to write the translation schema. The translation schema for this grammar. Let's see. So the production rules and the semantic actions that combinedly called as the syntax directed translation. So that we already know. So let's see what is the translation schema for this grammar. How you are going to write the translation schema for this grammar. So let's take the first production. The first production is S determines id is equal to e. For this production, what is the action that it has to be taken? So whatever the production that it looks like this and what is the action that it has to be performed. The semantic action is P is equal to lookup. Okay, let's take P is equal to lookup id dot name. So here it's id, it's an identifier. So whatever the id dot name, it's something a value. Okay, it's maybe a real or integer or whatever it may be. That value will be assigned to the P. By seeing the lookup table means it's a symbol table. You have to check the symbol table. So id dot name symbol in the symbol table, if id dot name is present, so you have to write that symbol table value assigned to the P. Okay, so don't be confused. Id dot name is present in some way. So for that, a value will be there in the symbol table. So lookup means it's a symbol table. You have to go to the symbol table. So there the value will be assigned to id dot name. That value will be assigned to P. Okay. Suppose if P is not a null, means some value is present. Means in the lookup table, id dot name is present. So if P is not equal to null, then emit P is equal to e dot place. So emit means we have to generate 3 address code. A 3 address code will be generated for the P value. That means e dot place will be assigned to P. That is a 3 address code will be assigned to the P. Suppose if it is not, if P is null means it displays error. Okay. So that is this production rule action. So whenever this production rule is occur while you are passing to the reduction, okay, so then it has to be checked. The id dot name is present in the symbol table. That number should be assigned to P. Suppose if it is not present, it displays error. If it is present, means it's a value is there, then you have to generate a 3 address code and that 3 address will be placed on the P value. Now let's coming to the second production. E determines E1 plus E2. That means the action for this production is e dot place is equal to new temp. Means you have to assign a temporary variable to e dot place. E dot place you have to assign a temporary variable. Let us take T1. Okay. So now e dot place is holding the temporary variable. Now you have to be generate emit means you have to generate 3 address code. The 3 address code, that is e1 dot place plus e2 dot place, will be assigned to T1 value. So now the T1 will holds the e1 dot place value and e2 dot place value. So whatever the values that is there in this for these two, that will be assigned to temporary variable. That is the second production. Now let's see the third production. The third production was E determines E1 into E2. So what is the action for this production? Okay. So here, just like E1 plus E2, E1 into E2 is also the same. E dot place is equal to new temp. Means E dot place is assigned to a new temporary variable, let's take T2. Okay, so now we have to generate a 3 address code for this. That is T2 is equal to E1 dot place into E2 dot place. So whatever the values that are present for E1 dot place and E2 dot place, that values will be assigned to the temporary variable. That is the prediction number 3. Now 4. The 4 is E determines within the parenthesis E1. So just assign E dot place is equal to E1 dot place. Next 5th, E determines ID. So whenever the ID is present, again you have to check for the symbol table, lookup. So ID means a value. So this should be assigned to P. Okay. So the P is lookup of ID dot name. So suppose if ID dot name is present in the symbol table, that number will be assigned to the P value. So if P is not equal to none, then generate a 3 address code. Okay. Suppose P is a null value, means ID dot name is not present, then it displays error message. Okay. So these are the production rules for the translation of assignment statements. So for this assignment statements, this is the actions that has to be performed. So here whatever the P that we are taking, this P returns the entry for ID dot name in the symbol table. Okay, and the emit function is used for appending the 3 address code to the output file, otherwise it will report an error. Then coming to the new temp. The new temp is a function used to generate a new temporary variable. Okay, and E dot place, whatever the E dot place here, this E dot place holds the value of E. So these are the rules, terms that we used in the semantic actions. So let's take a simple example to explain this translation of assignment statement. Let me take one example. With the help of these productions and the semantic actions, you have to do this thing. So let's take x is equal to a plus b star c. So this is an expression I had taken. So for this expression, let's take s as a value. Let's take, these are all the IDs, ID, ID, ID. Okay. So ID is equal to, and complete this expression is, let's take something, or else you just take these productions, not this. We have to produce this expression, the output has to be like this, and with the help of these productions you have to get this output. So first S determines ID is equal to E. S determines ID is equal to E. So next E determines E1 plus E2. Okay, E determines E1 plus E2. Okay, again E determines E1 star E2. So first E determines, this is ID, and this E determines E star E. So just whatever the productions here is, that I am representing in the parts tree. So this is ID and this is ID. Okay, so for these IDs, these are the values here. This is the X and this is A. X is equal to A plus B star C. Okay, so this is the expression. That expression will be represented by using these productions. Okay, now let's see the translation of assignment statement. That is, we have to write the intermediate code for this with the help of this SDT. So top down approach, there is no reduction here. Here there is no reduction, and come to here. So here reduction is there. E determines ID, means ID is reduced to E. Okay, so this is a reduction is there. So whenever there is reduction, means E determines ID. E determines ID. So first go to that production. For that production you have to see the action for that production. So E determines ID is the production. What is the action for this production? You have to check P is equal to lookup. Okay, ID dot name. So what is the ID dot name here? The ID dot name is A. Okay, now P is equal to A now. Okay, so the P is equal to A. So if P not equal to null, right, means the P is holding A value. So P not equal to null. Whenever it is not equal to null means it has to produce a 3 address code, that is P is equal to E dot place. So this is a E dot place. So what is the P value here? A. Okay. Now E dot place is holding the A value. Now come to here, there is no reduction. Again here this is reduction. E determines ID. Okay. So here also E determines ID means the fifth production. Again you come to here. So P is equal to lookup of ID dot name. Here the ID dot name is equal to B. Means the P is holding some value. Let's take a B value. So P is not equal to null. So then emit, that is generate a 3 address code, that is P is equal to E dot place. So in the E dot place you have to write the value of P. What is the value of P? B. Again come. Here the reduction is there. So same, E determines ID. So fifth production, same procedure. So here the ID dot name, that is the P is equal to C now. It is not equal to null, then generate a 3 address code and E dot place should be P. So here E dot place is equal to C. Okay. So A, B, C. Now come here. So whenever I coming here, okay. So for this, what is the value? For this, the reduction is E determines E into E. E determines E into E. This is the third production. So for this production, what is the action? E dot place is equal to, let's take new temporary variable. A temporary variable, let's take T1. Okay. So E dot place is equal to new temp variable T1. So emit E dot place is equal to E1 dot place into E2 dot place. Okay. So now T1 consisting of E1 dot place B, E2 dot place C. So T1 consisting of B star C. Okay. Again go up. Again there is a reduction. E determines E plus E. So whenever E determines E plus E means, you have to take E plus E dot place is a new temporary variable. So let's take the temporary variable is T2. Okay. So for T2, emit E dot place is equal to E1 dot place plus E2 dot place. So what is the E1 dot place? A. And what is E2 dot place? T1 plus T1. Okay. Now come to here, and this one is the final thing, the S. Here X is equal to the first production. S determines, check here, the first production. S determines ID is equal to E. Okay. So here S determines ID is equal to E. So whenever this is equal to, just see the action. So you have to place that E dot place. So now X is equal to T2. X is equal to T2. So this is how you have to generate an intermediate code for the translation of assignment by using the translation of assignment statement. Thank you.